So before we get started with example 3, I do want to give a quick comment on this type of example, the 52 card deck, right? So this type of start again in 3, 2, 1. So I do want to make a quick comment before we actually go into example 3, because not everyone is familiar with the standard 52 card deck. When it comes to this, there's typical games that we can play, for example, poker or blackjack, but not everyone is familiar with those games. So when it comes to a test, for example, don't expect this to be one of the questions that you'll ever see. It wouldn't be a fair question to ask. Not everyone is familiar with it. So I'll be omitting questions like this from an exam. Now, because it is still probability, it's still an important and intriguing problem to look at. So I still want to discuss this in the homework assignment. And in the handout, what you see on the right-hand side is the solution, which is at the very end of the handout. Okay, so all my handouts have solutions at the end. So feel free to look at these. And I went into detail with this one especially because I want everyone to be on the same page when it comes to this. But I do want to discuss example 3 now though. So here, suppose we have a single card that is randomly drawn from a standard 52 card deck. The 52 card deck is this, okay, so we have the numbers 2 through 9, then 10, Jack, Queen, King, Ace. That's 13 cards there. And we have 4 symbols or 4 suits. The 4 suits are hearts, diamonds, clubs, and spades, okay? So 13 cards each, that makes the sample space 52 cards, okay? And the reason we discuss this in this chapter, in this section specifically, is because we're talking about the addition rule with the keyword or. And we can apply that to even something like this. So let me show you. First, for part A, we want to find the probability of drawing a king. So here, notice that we're using the classical rule here, the number of kings over the number in the sample space. And the reason why is because imagine if all these cards are flipped face down and you shuffle them all on the table, you select one card at random. That's the experiment here. Suppose a single card is drawn at random. Each one of those cards is equally likely to be selected. And that's the key for the classical rule. So here, the probability of king is equal to the number of kings over the number in the sample space. So the number of kings, here we can count 1, 2, 3, and 4. So we have 4 in the numerator. And the number in the sample space, that's overall 52. So 4 out of 52, 1 out of 13, we can also reduce that to its decimal form as well. Now, part B, there's something interesting here. They introduce a keyword. Find the probability of drawing a king or queen. The keyword is or. And if you recall, or has 2 formulas in probability, okay? If you have 2 disjoint events, so imagine a Venn diagram with disjoint circles or separate circles. Here we use the first formula. If you have overlapping circles or overlapping events, imagine a Venn diagram with overlapping events, we have to use the second formula. So when it comes to part B, we need to ask ourselves, to find the probability of drawing a king or queen, can king or queen overlap? Okay, so when you draw a single card, is it possible for that single card to be both events? So imagine you draw one card at random, you take a look at that card, and you ask yourself, is it possible for this single card in my hand to be both king and queen? And the answer is no. There is no overlap between the 2 events. That single card cannot be both, okay? So these events are separate, disjoint. So if you notice down here, we're using the disjoint formula. The probability of king or queen is equal to the probability of king plus probability of queen, okay? So here we can take the classical rule, the number of kings over the number in the sample space, plus the number of queens over the number in the sample space, where the kings, there are 4 out of 52, plus the number of queens, there's also 4 out of 52. Okay, that'll come out to 2 out of 13. So it's interesting because even with addition rule, that can still be applied for an experiment like this. In part C, now we're looking for the probability of drawing a heart. Okay, so in part C, notice here, we have using capital H. Typically, again, in statistics, we do like to use corresponding events and letters that correspond together nicely. So let's use capital H to define the event heart. The probability of heart is equal to the number of hearts in the deck over the number in the sample space. So if you count the heart here, there are 13 hearts in a standard 52 card deck. So that's going to be 13 divided by 52. That'll be 1/4. Okay. Now, this is going to lead into part D, where part D says, find the probability of drawing a queen or heart. Okay. So it's the same thing as before. We see the keyword or. There are 2 formulas when it comes to the keyword or. We need to ask ourselves, is it possible for queen and heart to happen in a single card? So once again, imagine here you draw 1 card at random, and you take a look at the card and you ask yourself, is it possible for that single card to be both queen and heart? Is it possible for that card to have both events? Okay, and if you notice, queen and heart is right here. So the answer is yes. There's an overlap between the 2 events. So we need to use the second formula this time, okay, because there is an overlap. So notice here we're using the overlapping formula. The probability of queen or heart is the number of queens over the number in the sample space plus the number of hearts over the number in the sample space minus the overlap. How many cards that both events occur over the number in the sample space. Okay, so here a quick note, there's only 1 queen of hearts. Okay, so the number of overlaps that occur is 1 out of 52, and that 1 card once again is right here. So by using the formula, here we have the probability of queen or heart. Okay, so that's going to be the number of queens. There's 4 queens out of 52 cards, plus the number of hearts. There's 13 out of 52. Okay, and then here we have minus the overlap, where we have 1 overlap, 1 queen of heart out of 52, and that simplifies to 4 out of 13.